Hello engineers, may I audible? Hello, may I audible? Okay, okay sir. No dear, we are going for LTSpice or we can use a cadence for so. For now, for today we are going for what LTSpice. Maybe next time we can go for uh, cadence virtuoso. Okay, so this is a LTSpice. Okay, so as per that, we discussed some RC based circuit on Sunday and that Thursday. Now we are going to simulate that circuit so that you can understand how that response is going on. How can you give that input voltage? What will be the RC? How it will be? Tau will be effect in your circuit. Okay, so let's start with this. Okay, so you just simulate, just install the LTSpice. There is no other any rocket science. Just simulate that. Just install LTSpice. Just go for next, and it will install. After that, you will show that okay, you have a new schematic. Just click on the new schematic, and you will find this type of window. And you have basic elements like ground, voltage, resistor, capacitor, inductor, diode, and we have a components. Okay, in this component section you have a lot of component, like you have a diode, you have a current, you have a current switch. Okay, you have a NMOS, PMOS, LED. Okay, so as per the requirement of your circuit you can take from the component. Okay, so let's start with a very basic circuit that you have a voltage source, and if you want to escape that, so just press escape. It will remove from your mouse. So just a voltage source, you have a resistance. Okay, so if you want to rotate from this point also, or you can press Control R also. Okay, so you press Control R, it will be here. So this is the way, and escape it. Okay, and you have a capacitor here, and just connect with the help of wire. So you have this wire, or you can press directly short key the W. So press W and you can connect it like this. Okay, so you can connect in a way. Okay, so I am designing first circuit where that input is 0 till 0, and after t is equal to 0 it is constant 10 volt, and the rising time is very small as compared that time duration given for the input voltage. So whenever you are providing the supply and resistor capacitor, you require a ground. So I am just writing that here it is ground. Okay, so you can put that value of R and C. Whenever you want to put that R and C value, just right click on the element, just right click on this, and it will show that what you can want to put that value. So let I am putting that the resistance value is 1 kilo ohm. I am not going for tolerance or power rating. I am just giving that very basic value that resistance have a 1k. Okay, and that capacitor, that let this one is 1 microfarad, so that you can basically understand what is the basic calculation of tau. So that tau is equal to R into C. So R is 1k and C is 1 micro. So is 1 kilo into 1 micro, it become a 1 millisecond. Okay, so the tau is 1 millisecond, and you can set your input voltage. So you just click on the right hand side of that voltage element, and you find that DC voltage, or you have advanced, you can set that input waveform as per your requirement. So we have a lot of input waveform ways, that is pulse, sinusoidal, exponential, and this is signal frequency, frequency modulation, pulse width, logic. Okay, and you can also add pulse width logic file. Okay, you have any file simulation, so you can set it. So I am starting with the pulse width logic, because I am generating our own waveform, because as per the time dependency we want that okay, your input till T1 is 0, after T1 become a 10 volt and suddenly and it maintain 10 volt. So that's why you require to own your waveform, that is pulse width logic. So I am saying that till 1 millisecond, I am writing that till 1 millisecond, that I am not writing S because this is given that S. So just I am writing till 1 milli, the value is 0. And a very small duration, let I am saying that this is in 1 microsecond, it is rises to 10 volt. Okay, so at time t1 means till t1 1 millisecond, that the input voltage remains 0, and in 1.001 millisecond means 1.001 means 1 in 1 microsecond, the difference of 1 microsecond, it is rises to 10 volt. Okay, and just maintain that 10 volt. So I am not changing after 10 volt, it is maintained 10 volt. Press OK. So this is that the pulse width logic of 1 milli till 1 millisecond, it is 0, and it have a sudden change is happening at until 1.001 millisecond, it is 10 volt. Okay, and you can give the node name also, you can give that labeling here. So just click on the label net, you can write it, okay, this is V in, so this will be your input, or this can be your V out as per your define. Okay, so you can label your net also. Okay, so this is the input, this is your output, the resistance value is 1k and capacitor value is 1 micro, and you have a input waveform in a way. So just I design this logic circuit and just simulate it. For the simulation, you just go for run simulation, just click on this, and that you have a lot of that analysis, that you can transient, you can AC, you can DC, you can noise, you can DC transfer, you can DC operating point, this is transient frequency. So as per the requirement, I will show you. Once we go for the MOSFET, we will find the DC operating point where you set your MOSFET in a saturation region. So that's why this is requirement. DC sweep, basically that is remaining that the input voltage sweeping from 0 to VDD. What is the output voltage? That is basically a DC sweep. You can sweep the voltage, you can sweep the current also. AC analysis, just simply that that x-axis will be a frequency domain. Okay, we have a different analysis. On the basis of that, I deliver that what is happening. So by the help of transient, you can simulate your output with respect of time. The time is moving on x-axis, your output is given on the basis of the time axis. Okay, AC analysis means your output with respect of frequency. It may be a Bode plot, just like in a Bode plot, you find that gain margin, phase plot, gain plot. You can DC sweep, basically you are sweeping the DC voltage or DC current on x-axis, and your output on the waveform, okay, it is VDD or 0 or something value. Okay, so this is the way you can. Okay, so as per the requirement, we are going for that. For now, I am just going for transient, because that the output in terms of transient only, that the input is in transient. So I am just focusing on that what is happening with the respect of time. So stop time is, let this is 10 millisecond. Why I am taking the 10 millisecond? Because till 1 millisecond, the input is 0. After 1 millisecond, it is rising to 10 volt in a 1 microsecond difference, and is maintained 10 volt. Why I am not taking that much more time? Because if you taking that much time now, it will take a difference of delta t. So I want to sudden change. So that's why I take a very small time, that is 1 microsecond. In a 1 microsecond, it rises to 10 volt. Okay, so just I am saying that okay, this is the way, and that this is 10 millisecond it will. Okay, so when you simulate it, you find that simulation graph. Okay, this is the output response, it is given on the black sheet. Okay, when you click on this, so this will give you a voltage. Okay, whenever you go for node, it will give the voltage. Whenever you go for that that element side, it will give the current. Okay, So just focus on it ki where you are selecting that ki okay, if you want voltage, that input voltage waveform, just click on this. It will showing that okay, till 1 millisecond it is 0 volt, and after 1 millisecond it have a sudden change of 10 volt, is maintained 10 volt, as like our input waveform in the first question. We define in a way ki okay, the input voltage is 0 till 0 millisecond 0 time, and after 0 time it is 1 volt. Now I am taking 1 millisecond, till 1 millisecond it is 0 volt, after 1 millisecond become a 10 volt there. Okay, so we can design our own waveform, okay, on the basis of that what is happening on the output side. So you can check it at the output side. Your output is going in a way such like this, that is an exponential graph. If you remember that last class of that Sunday, we discussed that that output will be rising exponentially by the help of dy by dx plus py is equal to 0. This is the first order differential equation. On the basis of that, you find that cf and pi. So you generalize one equation, that is v out is equal to v out final plus v out initial minus v out final e power minus t by tau. It is not only for v out, it is for everywhere. You can use for current also, you can use for capacitor, you can use for resistor. Everywhere you can use this this equation, just like y is equal to mx plus c. Okay, so your output is rising to 10 volt. Your output is rising to 10 volt with the time constant. Okay, so if I am saying that okay, if you are taking a single time constant, if you are taking a single time constant, the output will be reaches to 63% of the maximum value. Okay, so if you take like this in a way such that ki okay, just focusing on this ki okay, I am just click on that v out, and I am focusing at ki what is happening at tau. So this is started from 1 millisecond, and tau is your 1 millisecond. So after 1 millisecond that will be a 2 millisecond. At 2 millisecond, what is your output? This will give you that output at tau. So that is v out is equal to v final plus v initial minus v final e power minus t by tau. So you can say that by the equation you will find it 10 1 minus e power minus t by tau. If t is equal to tau at time constant, you will find that that is 10 1 minus e power minus 1, that is e power minus 1 is 0.36, and 1 minus 0.36 0.63, or 0.63. So 10 into 0.6, that is nearly about 6.3 volt. So just check it at 2 millisecond, nearly about 2 millisecond, you will find that the voltage is 6.34 volt. Okay, that is nearly about 6.3 volt. So if that waveform in a way, if the input waveform in a way, the output is moving exponentially, but it depends on the time constant, that the waveform, the output waveform, it depends on two things. One is that output depends on the time constant and the pulse width. Okay, so the time constant decided by the circuit, and the pulse width decided by the input voltage. In this, the input voltage have a unit step input, just like that, that is ut minus 1 millisecond. After 1 millisecond is a unit step input of 10 ut minus 1 millisecond. This is a 10, that is 10 volt. Okay, and it is maintained 10 volt. So as like this, the capacitor is charging from 0 to 10 volt, but once it is reaching to 10 volt, that the capacitor act like an open circuit. So if you are looking, this is a non-linear function. It is not a linear function, this is a non-linear function. So if you are thinking in a way, in a single tau, it is reaches to 6.3 volt. If you talk about 2 tau, means what is 2 tau? Basically after 1 millisecond, 2 tau means 2 millisecond. So if you talk about at 3 millisecond, your output it become at 3 millisecond nearly about 8.6 volt. So you just think in a way that output is exponentially rising. It is not linearly rising. So if the output voltage is not linearly rising, that will be a problem. Okay, it is good for that. Okay, whenever you have a RC circuit, you find in a way. But once you want that key, okay, you want a linear output, so it is not for us. Okay, so that is the way you can understand at 3 millisecond that exponential graph is coming. So you can think about what is happening at 3 tau. So at 3 tau means this is after 1 millisecond, this is 3 millisecond. You can find it, okay, at 4 millisecond is 9.5 volt, and at 4 tau it is 9.8. At nearly 5 tau, just I think that just I discuss in a last class कि whenever you are reaches to 5 tau, it is a steady state error, it is very small. So this is that at 5 tau, 5 tau means that 5 into tau, that is time constant. Whenever you are reaching to 5 tau, after the input voltage is rising, you find that you will reach to maximum voltage. If it is charging, so it will take maximum voltage. If it is discharging, so it will discharge to 0. So at 5 tau, you will find that the output voltage is 9.93, so nearly about 10 volt. Okay, so this is the way you can, okay, as per the time is increases, as per the time is going on, it is reaches, it is trying towards 10 volt, but perfectly it will not going to 10 volt exactly. It is 9.99999 something, but it never be a 10 volt. Okay, that is a practical example. So you just think in a way ki, okay, you have a time that is 1 millisecond, and at 2 millisecond it is like this. If you want that key, okay, we want that different value, that at 2 millisecond it is that 6.2 volt or 6.3 volt. Okay, if you change the value of R and C, it will provide the different waveform also. Why? Means that as per your time constant is small, as fast that capacitor charge to 10 volt, as good is your tau, means as large your tau, as slow your output waveform. Okay, so just check this, okay, you have a tau, I am just changing that R value, I am moving that R to 1k to 5k. If R is 5k, what is happening? Your output waveform is decreasing, means that the output is not reaches to uh, at much level. You just focusing at here ki, okay, till 1 millisecond it is 0, but if your R is high, means the resistor, means current is limited, and what is the minimum current you have, what is the maximum current you have? I is equal to V in minus V out upon R, that is V in is 10 volt and V out is 0 at initially, so it will be 10 upon R, R is 5k, so this is 2 milliampere. So it is starting from 2 milliampere, but in previous it is starting from 10 milliampere. If the resistance value is high, the current will be limited as much as per the resistance will increases, as per the current which decreases, as per the capacitor is charging slowly, because I is equal to dq by dt and q is equal to integration of I dt. So as small your current, as capacitor charging charge is small. Okay, so if you are looking here, that capacitor is not charges to 10 volt till 10 millisecond. Why? Because now your tau become a 5 millisecond. At least you required a 25 millisecond after 1 milli. So means it is going for 26 millisecond, it will be become a 10, nearly about 10, 9.99 something, 9.9 something. Okay, if you going in a way, so you can just think that, okay, what is happening? The tau after 1 millisecond, the tau value is 5 millisecond. So at 6 millisecond, you can find it, this is the 6.3 volt. Just think it. At 6 millisecond, the voltage, the output voltage is 6.3 volt. So if you know the basic thing now, you can understand. Okay, I designed one question in a last class. Okay, you have a that clock, and the second clock, the output is the frequency multiplier. what can you design, what can you do in the circuit. So mostly people's understand, a student understand we can do with the help of RC, but it cannot. But if you are going for a precise way, the RC will not give a linear path, it is give that non-linear path. So for a charging time, if you are charging from 0 to 1 volt, for 0.5 volt it is taking some time, but it is not equal for a discharging time, because this is an exponential charging or discharging, and this is a non-linear graph. So if you are solving the question with the RC, you will not predict the exact value and you can't predict the exact output. This is okay for just okay, that is, it is similarly like, but it is not perfectly, because this is not a exponential, this is a exponential, this is a non-linear graph. Okay, so you can convert your linear non-linear graph into linear by the help of different circuit. Okay, you can, okay, we will discuss in the next class how can you make that capacitor is charging linearly. Whenever you have a resistor and capacitor and you have voltage, that capacitor is always charging exponentially, but by the help of current we can charge capacitor linearly. Okay, so as per the time is going on, that capacitor is charging, and from this point we can understand that capacitor is charging depends on that tau value. If tau value is high, capacitor will charge slowly because current will limit. Just focus on the current side. Whenever you explain your question or your problem in an interview, always define in terms of current. Here the current is 10 minus 0 upon R, that is 10 minus 0 upon 5K, that is 2 milliampere. In a previous question, that 10 minus 0 upon 1K, that is 10 milliampere. In a previous, the current flow is high as compared to in a second question, so that capacitor is not charging as much fast as much previous one. Okay, or similarly, if you reduce that resistance, it is not uh, 1K, it is 0.5K. If I am reducing that resistance, so what is happening, that tau, that I is what, that 10 minus 0 upon 0.5, that is 20 milliampere. Okay, so this is 20 milliampere. It is starting from the 20 milliampere. So just check it here. Okay, this is your input. Now your output is as fast. Why this is fast? Because tau is small. What is the value of tau? Tau is equal to 0.5 k into 1, that is 0.5 millisecond only. So nearly 1.5 millisecond it will reaches to 6.3, and 5 tau means 2.5 millisecond. At 2.5 millisecond it is nearly about 9 point something value. Means 3.5. After 1 millisecond 2.5, that is nearly 3.5. It will be nearly about 9.9 value. You can check it also there. So this is 0.5 time, that is, this is 0.5 means 1.5, so nearly 1.5, it is 6.3 volt. And if you talk about 5 tau means 5 into 0.5 millisecond, that is 2.5. After 1 millisecond, that is 2.5 become a 3.5. If you are thinking in a 3.5, it is nearly about 9.9 there. So this is the way you can understand. Okay, so LTSpice will give that result. Okay, of course you are designing your circuit in a pen and paper and find it, okay, what is happening on the output side and what will be the our R and C. Just not think in a way ki okay, capacitor is charging or discharging. Just think in a way ki why that it will affect by the help of tau, why it is happening, where the current is increases or decreases as per resistance is happening here. Okay, so you can focus on this part also. Okay, so if you want, you can check that key what will be the current. You can check it. Okay, this is the current. The current t is equal to 0, t is equal to 1 millisecond, it is 0, and the capacitor current or resistance current, because they are in series, so that capacitor current or resistance current is starting from 20 milliampere. Why? Because the 10 minus 0 upon 0.5 k, that is 20 milliampere. It is starting from 20 milliampere and is going on decreasing as per that I is equal to c dv by dt, or you can write is I of t is equal to I final plus I initial minus I final e power minus t by tau. As per that equation, you find that okay, how that current is exponentially decreasing, because that initially the current is the 20 milliampere, but as per time is going on, your capacitor voltage is increases. As per the capacitor voltage increases, just like delta, 2 delta, 3 delta, 4 delta, 5 delta, and 6 delta, just like that capacitor voltage increases as per the current is decreases, because I is equal to the input voltage is fixed, that is 10 volt, but V out is increases, that is 10 minus V out upon R. As per V out is increases, as per the current is decreases, so that at t is equal to 1 millisecond, just as per the input is become a 10 volt, your out that current is maximum there. But once that output voltage increases, your current is decreases, and the minimum current you will find it when the capacitor voltage become a 10 volt. So this is 10 minus 10 upon R, that becomes 0. Okay, so that current will be nearly reaches to 0, and that's why we are saying that at steady state capacitor act like a open circuit, and that time that current is not flowing, and the resistance does not have any voltage drop, and the voltage is here, that maximum voltage is retained by this supply or the circuit, that is 10 volt. I think you got my point, and don't just go for only that understanding of how the capacitor is charging, just simulate this circuit and that is okay. No, there, this is not enough for a circuit designer. You must have a basic understanding. Okay, we change that R value, what will be happen? If you change that capacitor value, what will happen? How can you make it the different value of R and C, and you find that different graph, because they are just find in your post layout simulation whenever you are going for a layout. Okay, so in a layout you will find that seat resistance, that is metal have a seat resistance, and you have a metal that is fringe. In a fringe you will find the capacitor, and that you have a clock. Of course these resistor or these capacitor is not are physically present in your circuit, but by the post layout simulation you will find that the metal have a resistance, that is C resistance, and metal will have a parasitic capacitance with the two metal is parallelly to each other, with C is equal to epsilon A by D. So you have a resistance also, you have a capacitor also. So this is unwanted effect in your circuit. So how can you, firstly you know what is happening here, on the basis of the skill programming, on the basis of the manually you go for the layout, you are increasing the contact of the metal, means you are increasing the conductivity of the metal, or you can say that you are reducing the resistance value, or if you are talking about the capacitor, you are increasing the distance between two metal, or you are using a different metal, means in place of M3 you are using M4 or M5, so that the distance is increases, so that you can reduce the capacitor. So you can reduce that these unwanted resistance capacitance effect in your circuit by the help of via conducting, or by the help of that metal, by the help of different metal. But firstly you must know what is happening in a such a way if you have a resistor capacitor, that will be influenced once you find that okay, you have a analog circuit and you simulate it, you find that okay, you have a slew rate, just you are simulating an op-amp. Okay, you have a OTA, or you are talking about the differential amplifier or single stage amplifier, or if you have a OTA, you have a slew rate. On the basis of that you find that your slew rate is high enough in a circuit design, that is good. That is 10 volt per microsecond, that is very good. 5 volt per microsecond, that is very good in your, as per your design specification in analog circuit. But once you go for that layout, you find that this is not 5 volt per microsecond, it is less than that. Okay, so the slew rate is small. So what is happening here? Basically, this will happen by the help of with the help of this parasitics resistor and capacitor due to the layout. So how can you compromise this value, and how can you change that this effect, or how can you minimize this effect? You are using a different metal or via or different things. Okay, so that's why you are learning this RC circuit. Okay. Okay, so this is the way, so you can understand that capacitor is charging. Okay, so this is happening here. And now I am talking about, okay, that I am just changing that input voltage. Now the input voltage is not 0 till T1. Before T1, or I can say that before T1 it have a voltage that is 10 volt, and after T1 the input voltage is suddenly 0. What is happening across that output side, and what is done by the capacitor? So I am just changing the input response. So let's think in a way where till 1 millisecond the input voltage is 10 volt. After 1.001 millisecond, means in a 1 microsecond, in a very partial time difference, that you will find that in a 1 millisecond it is 10 volt, and in a 1 microsecond difference it become a 0. So it is constant 10 volt till 1 millisecond. After 1 millisecond it become a 0. So just like this, it is a falling edge. Previous question it is a rising edge, and now you have a falling edge, and that the edge is falling in a 1 microsecond, it is falling to 0 volt from 10 volt. So what is happening? Once you firstly analyze in a way, okay, you have a 10 volt constant and it is 0 after t1 millisecond. So what is happening? So whenever you have a constant voltage, capacitor act like a open circuit in a steady state, so it will attach to maximum voltage, that is 10 volt. So till 1 millisecond the capacitor value is 10 volt. As per that input voltage become a 0, capacitor have a path to discharge. So it is discharging with a resistance path, and it is discharged exponentially, that is V out is equal to 10 e to the power minus t by tau in terms of that. So just understand a way, okay, in a falling side the input voltage is like this. It is not that it is not 0 to 1. I am just saying that this is maintained 10 volt till 1 millisecond, means till 1 millisecond it is 10 volt from a long period of time, and after 1 millisecond it is maintained 0. So what is happening here? So basically the input voltage remain 10 till T1, and after T1 it becomes 0, so it is connected to ground. So capacitor will discharge. Capacitor will just it is just like this, okay, you are in company, like you are in TI or ST, and you have a package of that is 50L, okay, that is CTC or 50L, okay, and once that anything happen in your company, and that company will that you have a layoff, okay, from the company, so you are in 0, okay. So till now you are not got that second company. You have that limited sources, means you have a bank balance only. On the bank balance you will discharge that. The capacitor is like your bank balance. You have a bank balance in your life, okay, and that if the input voltage, there is no any active source is present in your domain, so you just what you do, that this bank will help you, okay, so you can go for that, okay, you can market, okay, on your balance. So basically that capacitor is just like your bank, okay. Once you that this input voltage becomes 0, so this is discharging there. and so the input voltage is 10 volt till 1 millisecond. After 1 millisecond it is become 0 and it is maintained is 0. So your output is just like this, okay, it is maintained 10 volt until 1 millisecond, okay, and after 1 millisecond that capacitor is discharging. Why? Because this input voltage become 0, so this have a path to discharge here, and this is discharging to 0 volt. Okay, and what is the tau? That a tau is 0.5 into 1 micro, that is 0.5 millisecond. If you going for 0.5 millisecond, means at 1.5 millisecond you will find it the capacitor is discharged till 63%, or it is hold only 33%. Okay, so you can just check it. 37, just like what, that is at 1.5, that is 1.5, that is this is nearly about 3.6, that is 37 or 3.66. So it is in a charging time it is reaches to 63%, and in a discharging time it will discharge to 36% per second. Okay, discharge till, okay, so this is 3.6 volt. It is have a only of 3.6, it have a drop of 6.3. Okay, so this is the way you can understand. For a charging time, of course this is non-linear. For a charging or for a discharging you have a different thing. So for a charging it is taking 6.3 volt for a same time constant, and for a same time constant you will find that it is discharged till 6.3 and it is become a 3.6, that is only a 3.6 volt you have. Okay, so as per you are changing that time, you will find that it will discharge slowly. Here the discharging is very fastly. You can reduce that resistance value as fast it is discharging. If you increase the resistance value, it is discharging slowly. Or you can put that capacitor value also. You can increase that capacitance value. You will find that that this waveform is discharging slowly. That exponential graph is slowly discharging. So just I am making in a way, okay, that I am just changing, okay, that this is 1 micro, just make it 10 micro. So this is become a 5 millisecond, 0.5 k into 10 micro become a 5 millisecond. So till 5 millisecond, so you just check it, okay, the input voltage is like this, it is 10 volt and become a 0, and that capacitor is discharging slowly. Why it is slowly discharging? Because I is equal to C dV by dt, and now V out is equal to I up, the dV by dt is I by C. As per that capacitance value, as per I by C is small, as per dV out by dt is small. Okay, so V out is decreases, but it is not decreases as fast as per that previous case, because you have a less tau. Now the capacitance value is increases, so that I by C is very small, so that you will find it. Okay, so this is that capacitance is discharging, and if you talk about 0.5 k into 10 micro, it become a 5 millisecond. So you find it at 6 millisecond, it is nearly about what, 3.67 there. Okay, so this is the way you can understand. Okay, this is the way you can understand that capacitor is discharging or charging in such a way. So you can. Okay. So till now we discussed that you have a charging point, you have a discharging, that by the help of input voltage. I am just giving that basic example of RC. Okay, I can make this some different level, but now for basic understanding, whenever you are facing problem in RC, just go for this circuit only. You can solve any problem with the RC. Okay, you can solve any question if you are facing the problem in RC by this question only. Okay, and let's start with that. Okay, till now we are talking about rising or falling. Now I am making that input voltage in a way ki in this waveform you have a input rising also and falling also. Okay, that it is behave like a duty cycle, and in first phase I am thinking in a way the duty cycle of pulse width is very far away to time constant. Means the time constant is, let make this 1 micro. So that time constant is 0.5 k into 1 micro, that is 0.5 millisecond. Okay, so I am just thinking in a way that T2 minus D1, the pulse width, it is far away to time constant, that is 0.5 millisecond. So I am just designing the input voltage in a way, okay, till 1 millisecond it is 0, and at 1.001 millisecond become 10, and it is maintained 10 volt till 5 millisecond. Because why I am saying that 5 millisecond, because 0.5 it is a time constant, and t that 5 tau become a 2.5. After 1 millisecond it will be 3.5 if you add the 2.5 millisecond. So this is become 3.5 millisecond, and I am taking 5 millisecond, that is too much enough. You have extra 1.5 millisecond for sustainably reaches to maximum voltage. And then after I am talking about after 5 millisecond, if this is reducing to that falling to 0 volt. So I am just saying that the input voltage till 1 millisecond it is 0. 1.001 means the delta t is 1 microsecond, it is reaches to 10 volt. It is maintained 10 volt till 5 millisecond, means from 1 millisecond to 5 millisecond means that duration is 4 millisecond. Okay, so till 4 millisecond it is maintained, okay, that 4 millisecond. If you talk about tau, so tau is 0.5 millisecond of this circuit, and this is 5 tau is 2.5. So 1 plus 2.5 3.5 means 0.5 millisecond extra you have. Okay, and after 5 millisecond it is reaches to 0 volt, that have a difference, that have a fall time is 1 microsecond, and it is reaches to 0. Okay, and it is maintained 0. So what will happen? So I am just checking here, okay, the input, okay, so I missed that some value, okay, that, okay, I am not time, this is 5 millisecond, it is maintained 10. Okay, that the waveform is here till 1 millisecond it is 0, 1.001 millisecond become 10, till 5 millisecond become 10, and 5.001 milli it becomes 0. Please be focused on the making the input waveform. I am just thinking in a way, okay, your input is 1 millisecond, till 1 millisecond it is 0, after 1 millisecond become 10, and is maintained 10 till 5 millisecond. After 5 millisecond become sudden change it into be 0, and is maintained this 0. So just I am writing till 1 millisecond is 0, 1.001 millisecond become 10, and till 5 millisecond is maintained 10 volt, and at 5.001 means at 5 millisecond plus 1 microsecond it have a become 0, in a that it is falling in a 1 microsecond, the fall time it is 1 microsecond there. So just in a way, and just simulate it, and I am thinking, okay, this what is happening, the input is just like a duty cycle. Okay, it is providing that, okay, 1 millisecond will be a rise time, at 1 millisecond it will be reaches to 10 volt, at 5 millisecond it is reaches to 0 volt. So this is just like a clock pulse. So you have a rising edge or you have a falling edge. So whenever you are talking about the capacitor, you always focusing on rising or falling part, because at rising that suddenly change is happening, that capacitor does not allow sudden change. So what is the capacitor voltage hold initially? Similarly, if you, that it is fall, so it is like that ki what is the capacitor voltage initially it hold on that before 5 millisecond. Okay, so just I am writing in a way, and once you go for that output, so you find that ki okay, till 1 millisecond it is 0, after 1 millisecond to 5 millisecond means the difference is 4 millisecond, it is greater than 5 tau, so it nearly reaches to 10 volt, and after 10 volt, once that time is going on, after 5 millisecond the input voltage is going to 0, it is reaches to 0 volt also. So that the input voltage is that suddenly changes, but the output is reaches exponentially, because due to the RC circuit, that capacitor have a limit amount of current. It does not have a sudden change happening here. So capacitor will charge exponentially or discharge exponentially. So this is happening here, that capacitor is charging 10 volt with a time constant, and capacitor is discharging with a time constant. Okay, so you can, but here I am using the pulse width. The pulse width is far away to far 4 tau, means for the tau, the pulse width is what, that is 5 millisecond minus 1 millisecond, that is 4 millisecond. The pulse width is 4 millisecond, and the tau is on this question is 0.5 k into 1 micro. This is 0.5 millisecond here. So this is 0.5 millisecond, and the pulse width is 4 millimeter, is 8 times. This is 8 times of the tau. The pulse width is not is nearly 5 tau. It is greater than that. It is 8 tau. So that's why it is fully charging or discharging. If you change that, okay, if you change that R or C value, any of that, you will find it, okay, what will happen. So if you change it, that R is 1K, so what is happening, that input voltage, the resistance value is changed, so tau become a 1 millisecond. So tau is 1 millisecond. For fully charging, it required minimum 5 tau, but you give that only 4 milliseconds, so it will not charge fully to 10 volt, nearly about 10 volt. It is less than that. So please check this, okay, or you can use that basic equation 10 1 minus e की power minus t by tau, where t is what, that is 5 millisecond, 5 minus 1, that is 4 millisecond, upon tau is 1 millisecond. So this is e की power minus 4. So 1 minus e की power minus 4 into 10, that will be your value of V out before 5 millisecond, nearly at 5 millisecond. So you can check it. Okay, so the input voltage is like this, that till 1 millisecond it is 0, and after 5 millisecond it is 0, and between this you have that constant voltage, that is 10 volt. Now what is happening, your output is not reaches to 10, it is less than that. Why this is less than that? Because you are not providing too much time for charging. So capacitor will not reaches to 5 volt, nearly 10 volt. It is reaches to that 9.8. Why? This is 1 minus e की power minus 4 into 10, that is nearly about 9.8 volt. So that's why so capacitor charging or discharging, it depends on tau and depends on the time period of that. Okay, so please be focused whenever that interview ask in a way ki if you are charging or discharging with the help of RC, that capacitor charging, it depends on time constant also, and the second thing, capacitor is also depends on the what amount of time you are giving an input side, so it will charge. Okay, so it depends on the duty cycle also, and depends on the time constant. So both will be dependent. That's why that's define your capacitor charging or discharging. In this question, you are increases the time constant. You can increase as much time constant as you want, and you maintain that pulse width, that capacitor is not charging to 10 volt, is less than that, because you are not providing the sufficient time to capacitor charge. Okay, so capacitor will not charge fully, capacitor will not charge fully to 10 volt, it will be less than that. It depends on the basic equation. Okay, and you can put that value, what will be the value at 3, that is at 3 millisecond, that is means 2 tau, means that is 3 minus 1 millisecond, because till 1 millisecond is 0, after 3, that is this is a difference of 2 millisecond, means at 2 tau you can check it what is the output value there. So you can check this. Okay, you can check by this, or you can check by the help of basic equation, that is 10 1 minus e की power minus t by tau, where t is 3 minus 1, because it is starting from 1. So there is 2 millisecond upon tau is 1 millisecond, so 1 minus e की power minus 2. and you find it 1 minus e to the power minus 2 into 10, that will be nearly about 8.6, that is 86% nearly it is reaches to 2 tau. Okay, so you can, so this is the way ki capacitor is charging or discharging here, but it will depend on the pulse width, and it also depends on the time constant. Okay. So you can change your R and C value and you can make your own idea. This is not as simple you are thinking. Okay, you can improve that circuit, just like I designed one question. Okay, you have a pulse width and I want that this pulse width have a frequency f. Now I want a 2f. So what can you do in a circuit so it will perform a 2f? Okay, I gave an idea ki you use a RC circuit, but if you go for generally, this RC is not a linear, it is a non-linear. So it is reaching 0.5 time, 0.5 value, means 0 to 5 volt, it is taking different time, and 10 to 5 it will take a different time because it is exponential, it is not linear with respect of time. So if you understand my question, so please solve in a way ki how can you make this linearized. Okay, so this is the question. Okay, you can change the input waveform also, and you can reduce the duty cycle or you can increase the duty cycle. If you increase the duty cycle, capacitor have a sufficient time, it will maintain, it will reaches to 10 volt or reaches to 0 volt. Okay, and if you are not providing the sufficient time, so capacitor will not charge to 10 volt, it will less than that. Okay, and I am just changing that question here. Okay, till 1 millisecond it is 10 volt. Okay, I am just want that it is like this. Okay, it is maintained 10 volt, then it becomes 0. It is maintained 0, then become a 10 volt. So what is happening that till 1 millisecond it is 10 volt, and this is become 0. Till 5 millisecond it is maintained 0. Now it become 10. So I am just changing that the input waveform. So in a previous, the input waveform is like this, till 1 millisecond it is 0, and after this it become a 10 volt and it is maintained 10 volt till 5 millisecond and it become a 0. Now I am changing that the circuit, the input voltage maintain 10 volt. Now the input voltage is dropped suddenly at 1 millisecond and it is maintained 0. At 5 millisecond become 10 volt and is maintained 10 volt. So what will be the output waveform? So output waveform is like this. So just analyze firstly, intentionally you will think in a way that input voltage previously is 10 volts, so capacitor will charge maximum to 10 volt, the Vout is 10, and then that time is as per after 1 millisecond the input voltage is 0, so capacitor will discharge with the help of resistance, that is called tau. So capacitor will discharge slowly with the time constant, and the time constant is enough, so it will discharge 0, but the time constant is 1 millisecond and you are giving the pulse width is only 4 milliseconds, so it will not discharge till 0, it will discharge less than that. And once after 5 millisecond, once that time is increases, your input voltage suddenly changes to 10 volt, it is maintained 10 volt, so it will be reaches to 10 volt. Okay, so this is the way you can understand. Firstly, analyze intensely. Okay, you must make your intuition on that. Okay, what is happening on your pen and paper, and then after you go for simulation. If you go for directly a simulation, it will not help you. It will not give it any idea. You just simulate it. Okay, don't go for the direct simulation. Just firstly analyze the circuit in your mind or in a pen or paper and just find it, okay, what is happening. Okay, and if your output response that will be same as a simulation, so that is good for you. Okay, means you are understanding properly. Okay, so I am just changing that. Okay, what is happening here? So I have a input voltage. Now the input voltage is changing, it is 10 volt. Till 1 millisecond it is maintained 10 volt, it is maintained 5 milli after 1 millisecond to 5 millisecond it is maintained 0 volt, after 5 millisecond it become a 10 volt, means it have a different waveform the previous one. So now that what will be the output? So output is 10. It is not reaches to 0. Why it is not reaches to 0? Because it is not have enough voltage, enough time. It does not have enough time to discharge 0 volt, discharge till 0 volt. So that's why it is a problem for you that capacitor is not discharging. That's why I'm always saying that capacitor discharging depends on two things. One is tau, and the second was how much time you are giving to that circuit so that capacitor is discharging. The tau is 1 millisecond, but you are not giving a sufficient time for the discharging, so that's why it is not discharging till 0 volt. It is less than that. It is nearly about 0.12 and something like this. Just check it. Okay, what is that value? You just check it. That is nearly about 183 millivolt. Okay, that's 0.2, nearly 0.2 volt. It is the value. Okay, and after that it will be reaches. Okay, why this will be reaches to maximum? So because as per that, after this the time is going on, after 5 milliseconds that the time is going on and is maintained 10 volts, so it will be reaches to 10 volt. There is no problem. But once you decide the pulse width, whenever you decide the pulse width, means that capacitor have a limitation for charging and discharging. If the pulse width duration is not that much enough, that means nearly about 5 tau or greater than 5 tau, so it will not charge fully or it will not discharge fully. So please go on this question. Okay, I am just giving a very basic example. So how can you use a LTSpice? I just use this LTSpice, just use that, just go for the new schematic, just rewind this. Okay, just open the LTSpice, just go for new schematic, and you can take that from the basic. You require only basic components for a RC. I am not going for MOSFET, so that's why I am just taking from the resistor, capacitor, voltage, as per. Okay, we will discuss RL also if the time permit. Okay, we have a voltage, we have a resistor, we have a capacitor, and on the basis of that you can make your own idea. These are the idea you can understand, and this is only thing when you find that whenever you have a CMOS inverter, you have a cascade structure, you have a differential pair, you have a op amp, you have anything of the MOSFET related. Now these are the very important points. These are the only point where we will discuss. Okay, what is happening here? This is similar to RC circuit. Okay, so everything is related with the network and RC. So if you are good in this, in a understanding, so you can. So as an assignment you can take, you can change the position of resistor and capacitor and find it what will be the value. You just check that capacitor here and change that resistance value here, and you can find it what is happening. Okay, what will be the output waveform, how that output waveform is working. Because if you change the position of resistor and capacitor, you find that resistance is present here and capacitor is present here. So that capacitor is here, so this is V in minus V out is Vc, and V out is R, that is R, that is I into R. So that waveform is not starting from 0 to 10, it will start from 10 to 0. Okay, just check it, firstly go for that. Okay, just work on it, and then we go for diode. Okay, so tomorrow we will start diode based circuit. So I am using a diode in a RC circuit, and figure out what will be the output response if you are using a diode. So please read about the diode, what is anode, what is cathode, how it is forward bias, how it is reverse bias, what is happening. Okay, if you have an ideal diode, what will be happen, if it is a practical diode, what will happen. Okay, so please understand this basic part, then we will start tomorrow, that is diode based question with RC. Okay, so thank you so much for today. We are stopping here, and we are going for a stop at this point. Thank you so much. Okay, I am taking some question if you have. Yes, I need guide for the mixed signal. Okay, are you okay? No, I'm not okay. Tau, this is okay. That is okay. Good evening, everyone. Okay, what if you have a two capacitors? Yes, you have a two capacitor, that C is equal to C1 plus C2. Okay, that C become a C1 plus C2. You can think in a way, if you have a two capacitor, that capacitor will add. We will work on it. Okay, if you required, we will. Okay, hi sir. In a real IC design, what is the very first step we need to do when designing a circuit? Is the first of the W by L using ID formula. There it is depends on your design specification requirement. Most of that you will find that you have a ID, you have a power dissipation. Okay, whenever you have a question on a design specification, once you go for the ASIC designing part now, ASIC design flow, in a ASIC design flow you will find it. Okay, you have a that power dissipation, the VDD into ID, that will be a power dissipation. You have a drain current, and you can find it. Okay. Okay, and how to know acha, okay. It depends on the basis of the W by L, you can improve that your ID. Okay. How to know complete time for full charging or discharging? There, as per that, as per your equation, that is 10 1 minus e power minus t by tau. You find it as per time is increases, as per your exponential value is decreases. E power minus 1 is small, e power minus 2, e power minus 3, e power minus 4, e power minus 5 is very small. So this is the way. Okay, so if you reaches to e power minus 5, it is nearly about 0. So that's why I'm saying that nearly 5 tau will be your good be your will be a full charging time. Okay, okay, thank you so much everyone. Bye bye, take care.